वैलिस थ्योरम बोलो तभी भी चलेगा, ली वैलिस थ्योरम, ली वैलिस थ्योरम, LIOUVILLES. Okay, what is the statement here? The statement is if a function f is entire and bounded in the complex plane, then f of z, then that function is constant throughout the plane, okay. So read the statement once again. If a function is entire and bounded, what do you mean by entire? Correct. If a function is analytic on C, then it is called entire. Entire function means entire. I can write it as analytic. Analytic, not a single domain. It is analytic on whole C. Then it is called entire function. Just remember this word. Correct. If a function is entire and bounded, then it is constant throughout the plane. Correct. And the most important example of this is whether sine z is bounded. See, sine x, when x is your real number, sine x is bounded, you already know. Correct. Now is the question is sine z bounded? Correct. And the answer would be yes or no. What is your guess? Is sine z bounded? So how will you prove? Let us try to see. Observe that this sine z is analytic function. Correct. Analytic on C. Analytic means what? इसका कितना भी derivative करो, do anything with that, there is no issue. It is always differentiable around any neighborhood. So it is analytic on C. That means sin z is entire function. We want to check whether sin z is bounded. So let us suppose sin z is bounded. Suppose sin z is bounded. So by Lee-Valley theorem, can I say something? Lee-Valley theorem was saying that if a function is entire and bounded, then that is constant. That means what? I am telling sin z is entire function and I am assuming that sin z is bounded. So what would be my conclusion? That is sin z is constant, which is wrong. Definitely correct. Sin z is not constant, which is a contradiction. So what was my assumption which made me wrong? That is, I assume that sin z is bounded. Hence, sin z is not bounded. Not bounded. Correct. Same goes for cos z also. Same thing. So you need to make sure you need to remember these two words: entire and bounded. Analytic and bounded याद रखा तो भी चलेगा. Then the function is constant throughout the plane. Okay, that's simple as that. This is one thing, and fundamental theorem of algebra can also be derived from this. So I'll just let you think about this. Refer the book, that is your complex analysis Churchill book, and find the proof of fundamental theorem of algebra, and this also. What is fundamental theorem of algebra? Anyone? There are so many fundamental theorem. Correct. I want fundamental theorem of algebra. If you are having a polynomial, say p of z equal to e naught plus e1z plus so on z raised to n, where en is non-zero, because I would like to talk about degree n, where n is say greater than 1, has at least one zero. Correct. This is the statement. It has only at least one zero. Either it is odd, even I'm not considering that. Okay, think about it. I'm not considering whether it is odd, even. I don't care. I'm just saying that it has at least one zero in general. This is what your fundamental theorem of algebra. And later on, we reframe it that if you are having a odd degree, then it has exactly one, at least one real root. If it has odd degree, but complex में I can say at least one zero, तो कुछ फर्क नहीं पड़ता. And one more theorem, that is maximum modulus principle. See, what are the things I am doing today? Till now, this is not in your syllabus. I am just making you to explore, to think more. Maximum modulus principle. Okay, I'll just state it. Suppose that your function is bounded. That is, suppose that mod of f of z, that is less than equal to mod of f of z naught. There exists a point z naught such that f mod f of z is less than equal to mod f of z naught at each point. At each point z in some neighborhood of say mod of z minus z naught, that is less than say epsilon, in which f is analytic. F is analytic. Then f of z has the constant value, f of z naught throughout that neighborhood. That is clear. You already see that it is analytic in that neighborhood and it is bounded in that neighborhood. So bounded by which number, that will be your function ka value. So function is constant throughout that neighborhood. That function will be f of z naught. That's it. Okay? You just read it once again, you'll get to know. Or if I just reframe this statement, then you'll see that if your function is not constant, then it won't have any, like, see, I'll just put it. If a function f is analytic and not constant in a given domain D, then mod f of z has no maximum value, in D. That means it is not bounded. As simple as that. It has no maximum value. Correct? No maximum value. That means you can say that is there does not exist z naught such that mod f of z that is less than mod f of z naught. There does not exist. It is just contrapositive of the previous theorem, you can say. So I just wrote you in the different wording. And with the same theorem, I can say one corollary. That is, suppose that a function f is continuous on a closed bounded region R, and closed bounded, it is and that is analytic. That it is analytic and not constant. In the interior of R. In the interior of R, than the maximum value of f of z, than the maximum value of f of z, that is sorry, maximum value of mod f of z I should talk, in R, which is always reached, which is always reached, occurs somewhere on the boundary, somewhere on the boundary. That means if you are having a if your function is having maximum, then maximum will be attained on the boundary of R, and never in the interior, never in the interior. There are so many questions on CSR net also asking about this, that is whether function will have the maximum on the boundary or interior. So answer should be always it is on boundary, and same goes for minimum also, huh? Okay, so let us come back to our topic. So the next thing is Mobius transformation. Okay, so let us see what is Mobius transformation. This is in your syllabus. Okay, this is a part of your syllabus, the transformation, or first I'll write Mobius transformation. Okay, the transformation, say W or T of W, bolo jo bhi bolo, T of Z, that is equal to W, that is equal to it is better to write W equal to T of Z, like you used to write Y equal to F of X, and W equal to T of Z, that is equal to AZ plus B upon CZ plus D, such that AD minus BC is non-zero. So any transformation that looks like this, that is T of Z equal to AZ plus B upon CZ plus D, where E, B, C and D are complex constants. So this transformation is called linear fractional transformation or Mobius transformation. Linear fractional transformation or Mobius transformation. What do you say? Mobius transformation. Okay. So whenever you see a transformation like this, that is T of Z equal to AZ plus B upon CZ minus D, then that transformation will be called as Mobius transformation. Correct? Observe that you can write this whole equation of this form also. If you multiply W with this, then you will be having a form, what I'll write above can be written as, that is EZW plus BZ plus CW plus D. Correct? You can write where E, B, C, D will depend on your small a, B and C. Okay, so this is also transformation. Correct? Now one more observation. See, that is T of Z, that is equal to EZ plus B upon CZ plus D. If you are having say T1 and T2, so this always works like a matrix. Like a matrix you are having, say A, B, C, D. This transformation always works like a matrix. That is, if you want to talk about inverse of this matrix, inverse of this transformation, so वो क्या रहेगा देखो, it will be just inverse of that matrix. If you want to take the product of two transformation, it will just product. So inverse में क्या रहता है, matrix का inverse क्या रहता है, if you remember, it is minus D minus A, correct, and यहाँ पे शायद B और C Used to as it is. Correct? This is how you take the inverse, correct? So this will be and divide by 1 upon determinant. But see here, in if you divide by 1 upon determinant, so it will be determinant here, everywhere. And you can take from the numerator 1 upon determinant outside, and from the denominator also you can take that outside. So T inverse of Z will be just that, minus dw minus dz or dw लिखते हैं, and it will be T of w since it is inverse I'm talking about, minus dw plus b upon cw minus e. So this is inverse. Similarly multiplication, similarly you can talk about everything whatever you want, correct? For multiplication you just have to multiply the matrix. So this is how you should work here, correct? Now the question is that suppose you are given three values, say z1 equal to 1, z2 equal to 0, z3 equal to minus 1, mapped onto this, that is, say w1 equal to I, w2 equal to infinity, and w3 equal to 1. Suppose this is what you are given, you need to find that Mobius transformation. Find the Mobius transformation. This is the question. This is how the question will be there in the exam. Find the Mobius transformation. So you are given that this one goes to I, 0 goes to infinity, minus 1 goes. So you want to find what? You want to find T of Z, that is what? Ez plus B upon Cz plus D. So one simple way is to do this, that just substitute each of the value. That is what is T of 1. T of 1 you are having, this will be E plus B upon C plus D. And what is the value of T of 1? That is 1. So you'll be having an equation here, E plus B is same as C plus D. So just mark it. And what about the second one, T of 0? T of 0 is infinity. Okay, so T of 0 pehle put karte, that means what? It will be B upon D, and that is giving me infinity. Infinity means what? Your denominator should be 0. That means you, from this is infinity, that means your D is 0. From here I got the value of D. Correct, just observation. And what is the third guy? That is T of minus 1. That is put it here, it will be minus E plus B upon minus C plus D. And what is T of minus 1? They are saying it is 1. So what will be the answer? You are having minus E plus B, that is equal to minus C plus D. So these are the three equations. By using these three things you need to find the value of EB and EBCD, correct? uh, yeah. Okay, do you observe that D is 0? Yes. Do one thing. See, if your D is 0, then what is your transformation now? It is just Ez plus B upon CZ just, correct? So observe one thing. Can I write my E and B in terms of C? So that will be easy for me, correct? If I am able to write my E and B in terms of C, then in the denominator also it is C. So everything will be in terms of Z. Correct? That is what the technique is. So let us try to solve. Your D is 0. Let us D is 0. So from the first equation, I'll be having E plus B is equal to C. And from the second equation, I'll be having minus E plus minus B minus A plus B, that is equal to minus C. Correct? Minus A plus B equal to minus C. So we would like to get the value of A, B and C from here. Correct? Okay, so how do you solve this? You are having two equations, you add them, you'll get B in terms of C. What was my trick? I would like to get the value of E and B in terms of C. That is my trick, because I can cancel the C from both the side, correct? So what I'm doing the same thing. I just add these two. If you add these two, E and E get cancelled, you are having 2B and you are having this is 0. That means B is also 0 for me. So if my B is 0, so what I am having now, that is E equal to C. So if A is equal to C, so that's it. So can I do that now? My E equal to C, so E and C will cancel and Z comes T of Z equal to, wait, just I think I made some mistake here. Okay, yeah, so T of 1 was I. I'm sorry, this is I wrote 1 here. T of 1, this is I. So this is IC ID like this. Correct? So this is E plus B equal to IC, not just C. Correct? So if I subtract it, if I add it, so I'll be having what? Just erase this thing. I'm sorry for that. Okay. So here E get cancelled. Here I'm having 2B, and here I'm having what? C common, that is I minus 1. Correct? And what is the value of B? B equal to C times I minus 1 upon 2. So I got the value of B in terms of C. That is what I wanted. And now get the value of E in terms of C. So what is that? E equal to Ci minus B. And what is Ci minus, what is the value of B? That is C into I minus 1 by 2. So I can take C outside. So I'll be having what? I minus I plus 1 upon 2. Oh, sorry, this should be 2I, no? And divided by 2. So what will be this? E equal to C times I plus 1 upon 2. So I am having E also and B also in terms of C. That is what my motto was. So let us put it in the equation. So T of Z equal to EZ plus B upon CZ plus D. D is already 0. So now put the value of E and B. E I am having I plus C times I plus 1 upon 2 plus multiply by Z plus what is B, that is C into I minus 1 by 2. C into I minus 1 upon 2, and that is divided by CZ. So can I divide C? So if I divide it, I will be having I plus 1 Z plus I minus 1 multiply by 2Z. Correct? So this is your final answer. This is your T of Z. This is your Mobius transformation. Correct? Nice. So in the case of finding Mobius transformation, you will be always given three values. That is, one goes to this goes to this, and this goes to this. This is the first way. This is the simple way. That is directly you have to put and solve the value, solve for the value of ABCD. Correct. And there is one more technique that is called an implicit form to do that. So I don't have to substitute. I just have to substitute in the implicit form. So I'll just write an implicit form. What is that? It is say W minus W1 into W2 minus W3 upon W minus W3 and W2 minus W1. This should be equal to Z minus Z1 into Z2 minus Z3 and divide by Z minus Z3 into Z2 minus Z1. Remember one thing, how to remember this thing. You observe that this is W minus 1, 2, 3. Do you observe that in the numerator it is W minus W1, 1, 2, 3. So it is easy to remember. This is 1, 2, 3. And in the denominator it is ulta 3, 2, 1. That is 3, 2, 1. So it is simple. It is quite simple to do. Correct? W minus W1, W2, W3, W minus W3, 2, 1. 1, 2, 3, 3, 2, 1. Here WW, here ZZ. Okay. So by this implicit form, let us do the previous question जो हम लोगों ने पहले किया था. Same. Let us do the same thing. What was that? 1 0 minus 1 ना? हाँ. 1 0 minus 1 goes to I infinity 1. So let us see. That means what you are having, z1 z2 z3, you are having z1 equal to 1, z2 equal to 0, z3 equal to minus 1, and w1 you are having I, w2 you are having infinity, w3 equal to 1. So observe one thing, that is something, if something is infinity, so 1 upon infinity is 0, correct? I'm talking about limit. Okay, so let us put it in the formula. What is the formula? That is w minus w1 into w2 minus w3 upon w minus w3 into w3 to 1, no, w2 minus w1, that is equal to what? Z minus z1 into z2 minus z3, and that is divided by the z minus, that is z minus z3 into z2 minus z1. So this is what you are having. Just put it in the equation. Observe one thing before putting the solution. Just see once what is the infinity. W2 is infinity, no? So you just divide both the side by W2 here in this thing. If you divide both the side by W2, so I'll be having what? W minus W1, and here I'll be having 1 minus W3 by W2, and in the denominator also I will be having w minus w3, and if you divide by w2 I'll be having 1 minus w1 by w2, correct? I'm dividing by w2 both the side. Why I'm doing that? Because w2 is infinity, but I know 1 upon w2 it will be 0, and here there is no issue, so I'll be putting as it is z minus z1 and z2 minus z3, and it is divided by what? Z minus z3 into z2 minus z1. So this is what you are having, correct? Let us put the equation. Let us put it put the values.